All right, let's look at problem number 1.3 on density. Seems like it should be easy, but it's actually, like a lot of things, it's actually kind of tricky. So I'll do lead, and then I'll let you guys do aluminum on your own. So as I wrote down there, lead has a density of 11.34 grams for every centimeter cubed, and they want to know if you have 50 kilograms, then how big a sphere would you have? Okay, so there's a couple things going on here. We got to know about the volume of spheres, and we got to convert grams per centimeter cubed to kilograms. Okay, so that's what we got to do. So first off, they just say find the radius of lead and spheres. So that means we could use any unit we want. So we might as well stay in centimeters since we have centimeters already. But they also give us kilograms. They want to know if you have 50 kilograms, and we have 11.34 grams. Okay, so we're going to have to change grams to kilograms somewhere along the way. So that's one part of it. So there's, again, lots of ways to start doing this. But let's change the grams first. Kilo means 1,000, so that's something you should know. And so this is 50,000 grams. So right away we can just say, okay, let's say we have 50,000 grams of lead. So it's going to be a lot of centimeters cubed because 11.34, there's 11.34 grams per centimeter cubed. We have 50,000 of them. Okay, that's one part of it. So what is the volume of a lead sphere that we could have? So first off, let's see. You have to remember the formula for volume. Density, how dense something is the mass divided by volume. We want the volume. So let's see. Okay, there's the long way to do it. We want the V, so we can multiply V by both sides, multiply V on both sides. The V's cancel. And so mass is equal to density times volume, so we can do that. So we have V times D equals M. We want the volume by itself, so we can divide both sides by D now. Divide both sides by D. We get that. And so now we have only the volumes left over here. So volume is equal to the mass divided by density. That's like the long algebra way to do it, but it always works. It always works. If you have an equation like this, I'm going to write the original one again. Density is equal to mass divided by volume. It always works that you can switch the one at the bottom with the one at the top, because that's what we just did, right? So switch the V and the D. Right away, we know that volume is equal to mass divided by density, which is what we got over here. So once you do it the long way, the good algebra way, from now on, you can just say, oh, when we have a simple formula with something equals something else and there's something in the bottom, we can always switch those two. It always works. So volume is mass divided by density. So let's figure out the volume of what we have here. So our mass is 50,000 grams. 50 kilograms, so kilo just means 1,000, right? Replace kilo with 3 zeros. 50,000, 50 kilograms, divided by the density is 11.34 grams. Okay, now here's another trick. I'm going to write this the correct way as a fraction. Grams per centimeter cubed. Okay, now notice that we have a gram on the top and a gram on the bottom. They cancel. We have a centimeter cubed on the bottom of the bottom. That means it's on the top. Okay, something on the bottom of the bottom means it's on the top. So this will give us volume, which is centimeters cubed, which is what we want. So that makes sense. So now we just get our calculators out and go 50,000 divided by 11.34. And again, we know we'll get an answer in centimeters cubed. So let's do that. So 50,000 divided by 11.34, and I get 4409.171. I'm going to keep lots of decimal places. We can round off at the end. So that's 4407, what did I say, 0.171, and that's how many centimeter cubes we have. Okay, that's fine, but they want to know, now let's make it in a big ball, a big sphere. What's the radius of the sphere? So that's the second part of this problem. I kind of took up the whole board on this one, so I'm going to block off some space up here to do the second part of the problem. So you have to know the volume of a sphere. Okay, so the volume of a sphere, and you can look this up online. I think there's well, yeah, you can find it lots of places if you don't remember what it is. The volume of a sphere is given by the formula 4/3 pi times the radius cubed. Okay, so we know the volume. We know the volume is this. So we plug that into here, and then we just have to solve for the radius. So now it's an algebra problem. So our volume we have is 4407.171 centimeters cubed is equal to 4/3 pi r cubed. And now we solve for r. Now, notice the units should work out. We have a centimeter, a distance to the third power, and we have a distance, the radius to the third power. So it makes sense our radius will be in centimeters. So I'm just going to leave off the centimeters cubed. We know our answer is going to be in centimeters. And now we solve for r cubed. Well, first off, we got to get rid of this pi and the 4/3. Okay, so I'm going to put the r cubed on this side because that's what we're solving for. Just switch the equation around. So I have r cubed equals 4407.171. And let's see, we have a 4 pi in the top over here next to the r cubed. So there's going to be a 4 pi in the bottom over here. So divided by 4 pi, right? If it's on the 4 and a pi on the top on this side next to the r cubed, was over here, they're going to be on the bottom here. We have a 3 in the bottom. We multiply 3 by both sides. It's going to be on the top. So we multiply by 3 there. Okay, and again, you can do this in multiple steps. You can multiply 3 by both sides, divide 4 by both sides, divide pi by both sides. It's good to just get a habit like I did there. You don't want to skip too many steps. It's kind of dangerous. If you want to write it all out, you're welcome to. But it's good to eventually just get used to doing that. If it's multiplied in the top on one side, it's in the bottom on the other side. If it's in the top on one side, like the 4 and the pi, it's in the bottom on the other side. Bottom on one side, it's on the top of the other side. Okay, so let's multiply all this out now. So this times 3 divided by 4 divided by pi. Be really careful in your calculator that you do that right. So I have 4407.171 times 3 divided by 4 divided by pi equals, now I get 1052.1345. How many decimal places do you keep? I don't know. I'll just write down a bunch. 1052.13457. That's good enough. That's what r cubed is equal to. Now we have to find out what r is equal to. So r, we take the cube root of both sides, is equal to the cubed root of that number, 1052.13457. There's lots of ways to do this in a calculator. Most calculators don't have a cube root button, but to the cube root is the same as to the 1/3 power. So I could raise this to the 1/3 power. The way you do that, there's different ways to do it on different calculators. One way to do it is you put this number and then you put the symbol, so you go 1052.13457. You put this little hat symbol, some people call it a caret, to the 1/3 power, and a lot of times when you do that, you should put parentheses 1/3 power. Or go 0.33333333, lots and lots and lots of threes, that would work. But make sure you can do that. So try in your own calculator to make sure you get the same answer I do. So I'm going to go, oh, there's also a y to the x button. On my calculator, I have a y to the x, and that means I hit that, and then I can put in 1/3. And again, I want to use parentheses just to make sure. So which way should I do it in this calculator here? I'm going to do the y to the x, and then 1 divided by 3 equals 10.17, about 0.8. 10.17 is probably close enough. So this, I get 10.17, and we know the answer is in centimeters. That's the radius of our sphere. And then you check and see if you got it right. And they get 10.172. I rounded off. I got 10.171. There's a 0.08. That's close enough. If you get reasonably close to their answer, that's pretty good. Okay, lots of steps. These problems usually are all multi-step problems. First you do one thing, then you do the other thing. Let's go over what we did. First we changed the grams, 50 kilograms to 50,000 grams. Then we got our formula for volume is mass divided by density, 50,000 grams divided by the density. We got this big number. And then we had to use the volume for a sphere, 4/3 pi r cubed. We know what the volume is. We have to solve for r. And we just have to be really careful with our algebra. Okay, hopefully you understood that, made sense, and now you can try it for aluminum. And again, they have the answer, so you can make sure you did it right. Be really careful using a calculator. Again, so many people make mistakes with this step here, finding the 1/3, things like that. So, okay, hope that helps. Good luck.